Yes, good evening, everyone. I hope you can all see my screen. Yeah, I'm going to begin my presentation right away. This here that I'm sharing is going to be my wait a minute. Okay. Let's put it this one. Okay. I hope you can also have a view of my screen. I'm doing a chatbot, but chatbots work with text, not numerals. So most of the things in data exploratory that we are requested to do are to deal with numeric data. Yet I have text, so I'm going to be hinting about what is required of them, and then I do the part that is relevant to my project. And so as you can all see, yeah, they talked about a heat map. A heat map is a representation of of values in a table using colors. Like according, you can describe the range of values to be represented and by which color. So it can be a form of a table, but where values are represented by colors corresponding to to their their value. A correlation matrix it's a matrix that is produced from finding correlations of specific columns. I would say columns from other columns. So for each column, its correlation with other columns is got, and then what is mapped out of that is what is called the correlation matrix, a box plot. A box plot is a variation of values from their mean that is plotted within the interquartile range. So a box plot has lashes, outliers, and the mean, the first interquartile, and then the third interquartile. Then outlier plots, we have things such as, we can get outlier plots from things such as scattered plots, z-score. Z-score is when you're standardizing. So if you find values from the basic standardization, if you find values that are greater or less than, okay, that are greater than, or where the magnitude is greater than the value 3, the magnitude of the value is greater than the value 3 from the standard, that shows it's an outlier. The interquartile, well, of course, when you find a quartile and you find values that are lying outside there, then those become outliers. And scattered plots, after plotting a scattered plot, you specify the x value, the y values, then diagrammatically it will be showing you values that are off the charts. Then all these are to deal with numeric values. Yet for my project, I'm working with a chatbot which does text. So you understand the reason as to why I have none of these evaluation methods deployed. As you can see from my data set, I have text, I have flags, category, and intent. It's an intent recognition data set. Yeah, that's just the head view. Then we were told to do splitting our data sets so that I could apply in my data set. I'm going to split like in accordance to the intent. Like I want the dependent variable to be intent, and then the independent variables are going to be the flags, and then the utterance. The utterance are going to be the questions that the chamber is going to be interpreting. So then the category under which it's falling. So that could also be under my intent, but I'm just going to put it into the independent variables, such that it's much easier to determine exactly what intent you need. So I made a variable y, I labeled it intent a string, and then from the columns, from the total columns in DS, I dropped that very string, and then I got all the remaining columns and I assigned them to X. So X became my the independent variables. Then Y became the dependent variable. Then from sklearn, I imported train test split, train test split. It's a function that returns four variables. It returns the test and the train variables for the X and Y values. So the X values are the values that are, of course, yes, I said that independent. But now for the train set, the X values would be those values for the train set that are independent, and then for the Y set like that, values for the Y for the for the tests for the train set that are dependent are called the Y are called the Y train. Then it also applies for the test. Then so after importing train test, the four variables are x train, x test, y train, y test. Mapped them to the function itself. Gave it the values x and y, which I've described above here, and then also the size, like as in the percentage that I want to be allocated to the test. So the size is 0.03, and then they told us to split it to three: the validation, the test, and then the train. So in my very test data, I further split it into the validation and the test. So I said the validation, the X validation, X test, then the Y validation and Y test are equal to the train test. The same repetition, but this is just that I'm splitting now my test, like my initial test into two, the very test and also the validation. So that I implemented. And then the final thing that we're told to do to find a model. So all the models are okay, that they are not categorical. Like mine is categorical. It needs the natural language processing and not near manipulation of values. So there is no model that can work on that. But there are models such as neural networks. I saw a bunch by the way, but they all follow the same thing. Yeah, you assign the train values, then you make the values fit. You can also, there are some models where you can specify the maximum features and then also how many trees you're going to work with. Those things can be various. There's something called the grid mode or something like that. It gets pairs of values. Oh, it gets different pairs of values and then returns their accuracy scores versus the very pairs of the values themselves. So it can be used to get for you the best combination or the optimal combination of pairs of values. So now if you do tune testing would be tune testing of the hyperparameters, or those parameters that you can switch. You use the same model, but you just change their values to find other scores, other accuracy scores. Yeah. So now if you tune hypervalues, you come out with different results, but using the same model. So and the evaluation of validation test. So still back to my point. I am using text. So thank you for all listening. I hope you find me in my next presentation. Thank you and goodbye.